Alright guys, so in this video we're going to be looking at how to interface our DC motor through our MBED. Now some of the components that I have here, obviously we've got our MBED, we've got our breadboard. I've got a power supply here to give me a 5-volt supply. I'll look in another video of, I suppose, another way of giving an external 5-volt supply to drive the motor. And we've got a potentiometer, 10k potentiometer. What this will do is allow me to speed up and slow down my DC motor. I've got my DC motor chip, so it's an L293D chip, so standard DC motor chip to control the motor. I've got some dip switches that we're going to use to do the forward and reverse of the motor. I've also got 2 resistors. Now, the recommended resistor is a 2k resistor. I've also just got a standard 380 ohm resistor, but to be honest, I think you'll be able to run it without the resistor. Okay, so they are the components that we'll need, and we'll hop over into some of the wiring now next. So the first thing I've done here is I've just integrated my power supply. So at my power supply, we've got these little kind of bridge connections that can change between, you can see it there, 5 volts off and 3.3 volts. So I can do that on either side. So what I've just said is I've turned it off at the top here, so I'm making sure there's no power coming along these rails, and then I'm giving my external 5 volts along here, so a negative and a plus. So I've come up and I've just joined the ground to the ground of my MBED. And you can see I've just taken the standard 3.3 volts out of the MBED and given it a power rail along the top. So remember, this isn't, although it looks like it's connected up here, I've used the bridge connector to turn the motor, or the power supply off. You can see it's in the off connection. So there's nothing being supplied along here that's joining into this 3.3 volts. So that's its own supply. Okay. So the next step then is just to connect the upper potentiometer. So we've done that in another video, how we read in that value, so hopefully everyone's comfortable with that. But basically just connecting in ground to our common ground with our MBED and our power supply, taking the 5-volt power supply, and then taking our variable reading into one of the analog input pins on the MBED. Then we've added in a switch, so just taking 3.3 volts into one of the switches, and then coming out of the switches into a digital input pin. I've set a pin 9, and I've used a pull down resistor, so a 10k resistor there to just pull down the current, but I'm pretty sure we could get away with a lower one, or indeed none at all. We're on to our DC motor chip. So obviously just make sure you have the chip in the right orientation, or at least that you know where pin 1 and pin 16 are. Okay. And obviously make sure that it goes across the bridge of the breadboard, so that we're not connecting 2 pins together. Same with the switch. There are a number of ground pins that need to be added in first, so best to add them in first. And there are 2 pins that need to be connected to your external power supply that supplies the higher voltage. So again, consult the pin output diagram or the wiring diagram for this. We have our pulse width modulation pin that comes from the MBED, so make sure it's one of the PWM pins that goes into our DC motor chip. 2 green wires have been taken from our motor input pins, pretty much two pins coming out, 2 digital pins coming out of the MBED, and then going into the enable pins on the DC motor. And finally, it's a case of adding in your DC motor into the 2 output pins of the DC motor chip, and then testing your solution.